I received this email titled malware, JS and EXE from romsfun.com redirect via Discord CDN. It says, hello. I was recently downloading ROMs for games I already own on the Xbox 360 for use on a modded console. During the process, I encountered a drive-by download served via the Discord CDN or cloud delivery network. The file attempted to download was, reading very literally here, lesb1an mia khalife and all that .zip. They provided the original Discord CDN download link as well as a saved copy on Mediafire with a password-protected archive. The Discord CDN no longer serves the payload, but we can still work with it from the Mediafire link they provided. In this video, we'll take a look how this malware sample is made and what it does. So I am inside of my Windows 11 virtual machine, and I want to be sure to interact with this inside of a separate, isolated virtual environment. I can paste in the zip archive, and we can extract this. I'll use 7-zip and just extract this current directory, and they did tell us the password they set was the word infected, which is the usual standard for malware samples. I'll click OK, and now we have this new folder. Opening this up, we can see the contents with a single quote or apostrophe as the name of one of these files, and 1m4ges or images.js. Now, oftentimes on Windows operating systems, the .js file extension would actually map to a local native scripting language and program that could run. It refers to the JScript language, which is sort of a local dialect of what you might consider to be JavaScript, like client-side code in the web browser, but this is meant to run on the host with the Microsoft Windows-based script host. You might be familiar with that with WScript or CScript or other executables, but let's open it up in a text editor and see what that code really does. We'll open this .js file, and let's actually take a look at what that apostrophe might be by using the Detect It Easy tool. I do have DIE, or Detect It Easy, available and ready within this virtual machine, so let's try and browse to open that apostrophe file. Opening this, it looks like it is actually an executable. PE32, or Portable Executable, being the Microsoft and Windows programmer application file type, actually packed with UPX, or the Universal Packer. Just to experiment, let's try and rename that file to have a proper .exe file extension. And then we can see, oh, it actually has presumably a Firefox icon. Refreshing the Windows Explorer here, at least at first glance, this looks like a Firefox installer. We can explore that later when we get to some dynamic analysis, but for now, let's do the static analysis and see what this .js file seems to do. But wait just a second, before we go any further, please let me take just a quick moment to tell you about the sponsor of today's video. Security reviews, compliance audits, vendor questionnaires, risk assessments. Look, if you lead governance, risk, and compliance, or GRC, you know the reality. It's not just a job, it's pressure without pause. Drata exists to change that. Drata is the AI-native trust management platform built for modern GRC teams. So you don't just keep up, you lead. No more chasing evidence, drowning in spreadsheets, or repeating yourself in every security questionnaire. With Drata, you automate the heavy lift. Security questionnaires? Covered. Continuous evidence collection? Done. Internal and vendor risk management? Built in. And with AI questionnaire assistance, Drata goes beyond automation. It learns from your controls, evidence, and past responses, so you complete security reviews faster, with more confidence. No more scavenger hunts for audit evidence, no more rinse and repeat for every vendor. Just a single, real-time source of truth. And yes, this is SafeBase, a real-time trust center that builds trust and accelerates sales. It's not separate, it's by Drata. One platform, one team. Risk, compliance, and trust, all working as one. Whether you're scaling fast or operating globally, Drata adapts to your workflows, so you reduce risk, prove posture, and accelerate revenue. GRC doesn't have to be a reactive scramble. With Drata, it's strategic, proactive, and empowered. Learn more about the unified platform transforming GRC. Visit jh.live/Drata. Thanks to Drata for supporting this video. For now, let's do the static analysis and see what this .js file seems to do. At the very start of the file, it had some comments denoting, hey, maybe this is code part of ECMA script 5 and just like convenience or utility functions for working with this language. You can see notes of es5-shim.js and some functions that look like they're just putting together plumbing or staging things to continue to work with the programming language, but not actually do anything definitive or tactical for this script. On the right-hand side of the screen, though, you might be able to see in the Sublime Text minimap, there is a block of what looks like yellow text, and these are certainly more pertinent as to what the program or script might do. This is probably obfuscated code to actually have some functionality amongst a lot of other nonsense in the rest of this file. If I continue down, scrolling through the rest of the file, nothing else really sticks out other than that pattern of nonsense. Again, none of that code particularly does anything. It might do some operations that could potentially waste time or have all this to look like innocent and benign code just so a signature or any antivirus or automated security solutions might not take a second look at what this file actually is. That's all to fly under the radar, but we can see that payload way up at the top, or at least a part of the code smuggled in where we see they do start to work with some more sinister capability of the .js or JScript or local scripting languages on Windows. They define a variable sulfin pyrazone to a new ActiveX object like wscript.shell. That allows them to run some potential commands or actual command line tools that you might expect from cmd.exe or the command line. They determine the arguments that are provided to the script, and if there aren't any provided, which should happen by default, it'll end up running the command with wscript.shell cmd/c wscript based off of the current name of the script with another argument re-executado. Okay. Following that, we can see the other lines that have a lot of strings defined that look like gibberish or nonsense, but this is just an encoding or some other way to mask and hide the data for it to be able to do things later on. You can see in each of these sets, they end up taking the variable they've defined, flickery, uncoops, or terrains, and then replacing out some of the nonsense they're using to hide other info. Ultimately, we'll have clean variables at the end of this, or the actual data that it's using, because it ends up creating another ActiveX object that looks like it's going to end up using some web requests, or making communications to websites out on the internet. They define a user agent, like a custom client-side little tell for what application you're using, like Firefox or Chrome or regular web browsers that have a normal and natural user agent, but this has my custom agent /1.0. Then it determines the status code of the response of a web page they get, and then execute it as a new function with all the content inside of it. So it's really evaluating and running new code returned by that external website serving another payload. The other conditionals down here are just displaying an error message with whatever unique language you might be able to explore. But ultimately, now we have the wondering question. Okay, if this is a stager to run another payload based off of these obfuscated values, let's deobfuscate these and see what they're really doing. We know that these blocks are just doing string manipulation, and because it's in JavaScript, we could just let it evaluate only this code and determine what's the final value going to be for each of these variables. That'll help us make better sense as to what they actually try to open or what website they reach out to. So since it's just doing string manipulation, and we know that this is safe code to run, ultimately just to examine what these variables and values are, let's try and do this in a little interpreter, or the console even just in our web browser. I'll hit F12 on my keyboard to open up the developer tools, and then I'll hop over to the console tab. It won't let me paste things in right away, so we'll need to enter the syntax allow pasting, and that will allow us to then paste in whatever code we'd like. Now you could do this very same thing with Node.js or anything else you might like, but ultimately it'll determine all these variables for us. Working with the code in the browser console like this is just a quick way for us to play with JavaScript in this little sandbox, only using the code that we've made sense of and we know we can trust just to manipulate these strings. So the variable terrains is just the word get, meaning the HTTP method where we get a page. And that page is probably the value of our uncoops variable. Looks like that is a paste.ee link, like pastebin. The other variable at the very top was flickery, and that's defining that ActiveX object type to be able to make web requests from JScript. So now we want to know what's the contents of this pasty link. What is the other payload they're hosting on this website? Well, let's click to go find out. And we have more JavaScript, as we would expect. Well, really, JScript, right? Because this is running locally. Let me copy all this code and then explore it in our text editor so we have better syntax highlighting. We can paste this in and then save the file as like payload2.js. And I like to add another file extension just so I don't accidentally double click it. Now I'm going to hit Ctrl-Shift-P in Sublime Text to set the syntax to JavaScript just so I have that nice highlighting. And let's go start at the top. See what this does. Looks like presumably boilerplate functions like getResource here and things to work with arrays or loop through things again with different potential language support for other functions or syntax that they might want to use. None of this code sticks out quite yet, but then it does. Strange comments, couple message box calls that are commented out, but then ultimately it builds a file system object. Another ActiveX object with a variable called FSO, and another for wscript.shell. They get the current directory, but then define other functions to generate strings like based off of a GUID or unique identifier, query WMI or the Windows Management Instrumentation Framework, simple exit, even a wrapper around the message box function, which is interesting. And then they have a comment for an auto IT macro and a lot of other convenience functions to be able to enumerate and retrieve data, like the app data common directory, app data environment variable, the current executable path, process ID, querying from WMI, which is kind of neat, common files directory, computer name, other environment variables, etc., etc. All this stuff to be able to rapidly and conveniently interrogate or retrieve info about this computer. A lot of these functions are defined, but I'll admit, I don't end up seeing the code using these. And they all have this strange format where they have a comment with the function name and a little description above it, and then a commented message box calling that function, and an exit call also commented just underneath. It does, of course, have functionality to get the public IP address by querying the ifconfig.me website, and building out all these functions continues on and on and on. It is neat to see all this capability available within JScript, like having this all syntactic sugar readily accessible as convenience functions in that scripting language, but again, it only takes us getting to the very end of the file where we see payloads being ran. Other interesting comments though, we see what looks like Russian text for the drive get type function, but finally down below, we start to see another sinister set of syntax. More obfuscated variables, more data that is tucked away and hidden, masked with these characters, and then other comments that might clue us into what it could do, but in another language. Once all those strings are cleaned with more replace functions, it ends up executing this as a command with the wscript.shell ActiveX object running that on the command line. We can determine the true value of these variables the same way we did just previously in the browser console to work with JavaScript because the syntax is so similar to JScript, but let me just keep scrolling so you can see all of the other convenience functions available within this script. I don't want to beat a dead horse here, but it's all to show you that code is here, but not really used. So anyway, let's get the next payload or layer of this malware here while we're looking at the variables headstrong only, helicopsin, and soundstage. Copy these. Back inside of our console, I can paste all these in. And now I have soundstage as the variable that we see with the value being returned and displayed. It'll invoke PowerShell with the hidden window, no profile, and the execution policy set to bypass. Now let's look at our helicopsin variable, and that is a blob of base64 code, or at least PowerShell code that uses a base64 encoded variable, but ends up decoding it and evaluating it with invoke expression. What was the last variable that we needed to see? Some headstrong only thing? Oh, that is another base64 data blob. It's interesting that this value is seemingly the exact same as the other above because they call that variable, even in PowerShell, headstrong only. So this is all that we really need. And I'm going to copy all of this to let PowerShell deobfuscate or at least base64 decode, but I'm not going to copy the invoke expression because that's the commandlet to actually execute this code, right? That's a detonator. So if we grab just this benign and innocent syntax, let's go try to run that locally. Again, we're in our sandbox inside of our virtual machine, so this is A-OK. Let me open up PowerShell and then paste in this blob. Once that's all there, I can hit enter, and you'll see it ends up defining what would be preambulating as our variable, or that's stored. So if I examine what that is, well, it's more PowerShell code. This is not all that pretty, but let's try to take a look at it inside of our text editor. And what? We can call this, if we paste it in, I guess payload3.ps1.nerf, and I will set the syntax here to PowerShell, little plugin that you can install for Sublime Text. That will enable word wrap, but I actually want to toggle that off. And you can see some interesting stuff here. Let's try and clean this up. What I like to do is usually just find and replace all the semicolon characters with a new line, so that way it's at least logically broken up line by line. I'll do that with Control H, just to find and replace. And I'll have regex enabled with that .* icon on the very left, so I can add a \n for a new line character just after what we've already seen for semicolons. Now that isn't perfect, it will break some for loops or other capabilities, but at least rapidly cleans up what the gist of the code looks like. But I should actually get into a better habit of using Visual Studio Code. A lot of folks have told me and let me know you can actually use Visual Studio Code to beautify or clean up some PowerShell syntax. If you have the PowerShell formatter installed, you can Control-Shift-P and then type format document, or Shift-Alt-F, and that will help clean up and add indentation for all the stuff present in that PowerShell code. I'm going to copy this and bring us back to Sublime Text just because I like how that looks a little bit better. And now we can see this defines more variables. The word oboe-like set to VKFJ, bend some, decoding some base 64 data, and mallow placenta, of course, setting the UTF-8 raw text of that. They do this process again with tug to pipe and ducking and windmilled, and eventually end up actually adding a new assembly or some .NET or managed code capability. They use the system.drawing library, and this is really neat. They define a variable called coolaman, where they have a URL for a lost in space wallpaper.jpg. And then later on, you can see they actually use the system.net.web client capability to make another online web page or internet request, reaching out to and downloading what would be this JPEG file on archive.org. They set a user agent again, they download that data, and then they set this list of bytes to a variable ambient. Fun fact, these bytes, or the hexadecimal values, are actually the file signature and the magic byte for a bitmap file. So what they do with this ambient variable and list of bytes is actually use it as a marker, as something within the file where it's looping through each and every byte of the contents of this file and trying to track the position to determine, are we actually matching or seeing this string of bytes in the data of the .jpg file we download. They use opotherapy as the iterator to loop through the bytes in this file, and then they end up setting this DASWE variable to the current index, opotherapy, if they match and find that string of bytes. Now when they do something wild here. They actually go ahead and create a new memory stream object, write out the bytes that they've now extracted from that index within the image, and they make a subsequent bitmap image or picture based out of that data. Then here's the craziest thing, they actually loop through the X and Y coordinates, both the height and width, as you can see here, and they straight up extract the pixel data, like RGB or red, green, blue color values, to use as data. In fact, they're all bytes. They make up another payload that they've stored in the image. Granted, that is represented in base 64, so they decode that and then do a duplicative replace statement to add more noise. And then they end up loading an assembly based off of that data and invoking one specific class, again base 64 encoded. Eventually, they run that function with arguments that they define down here. interesting strings here: ms build, C users public downloads as a path, mystifiers, JS, isotoxin, and 2, and we can make more sense of those arguments later once we extract this next stage. But you can see these are the steps for it to extract another payload out of an image file, genuinely hosted on archive.org. So let's get back to our web browser and now try to go access that JPEG file, literally a wallpaper containing malware. I don't know about you, but I just think this is kind of funny and neat. Let's save that image here. And with that, let's decode some of the base 64 we saw in that PowerShell syntax. Back in the command line, we can just paste that in. We should have the variables windmilled set for class library 1.home, and whatever mallow placenta is just as well, the letters VAI. And let's actually take the code, all the PowerShell syntax that it naturally uses to be able to extract out and then find and load this .NET assembly. But I don't want to actually load the assembly. I just want to get all the data out of it. So let me actually put this in another buffer in our text editor. And before we then extract out the color values and all the pixel data, I actually want to save the image just to see what it looks like. So our extracranially variable could save with an output.bmp file. And then I think we need the arguments specifying the image format here. That type can just access and reference BMP. With that all staged, let's try and run this in PowerShell. Back on our command line, let's head over to the desktop, and then in the current directory here, we know we had the zip archive and the folder that we're working with, but if I paste all this code to download and extract out what would be the color values and another bitmap inside of this image, it ends up carving it out and saving our output.bmp. Oh, I've seen PowerShell do weird things where it puts it in just my user profile above the directory in the desktop, but now it should be present. So back on the desktop, this is our output.bitmap image that looks hysterical. Look at it, 100 by 13,708, almost 4 megabytes worth of payload in the color values of all of these pixels. And that is base 64 data for yet another stage. Honestly, this feels like a capture the flag challenge. Zooming out though, it is kind of neat to be able to see like, oh, the other indicators of like different parts of the file. Like you can see the different colors that are representing obviously different data and the like 255 bytes ASCII representation that they extract out, but that's just funny to see. Now let's get back to the part of our third payload in PowerShell after they have retrieved the bitmap data of that image, where they start to carve out all those RGB color values and then eventually load it as a .NET assembly. Now, I don't want to load it within PowerShell, but I want to extract out or carve out what that file is. So I'm going to copy that syntax and then again paste it into a new buffer for us to work with. And I want to use the system.io file type to be able to write all bytes of our radio photos value in another like output.dll, or I guess really payload 4 or 5, depending on if you consider the bitmap and JPEG, but that will take in the data from our radio photos variable. Now let's use all this back on our PowerShell command line. And again, I think that will put the file in my user profile, taking a little bit to carve through all those pixel data. There we go. Now we can write the payload, not yet in the current directory, but let me move it from just above into this directory. Now on the desktop, we have payload 4. Let me take a look at the properties here, just to see, presumably this is a Microsoft Win32 task scheduler, but I doubt it. Since it is a .NET assembly, we can use some tools like ILSpy or DNSpy, or I like to use .peek, to try to look at the bytecode, or enough of the syntax representation to understand what this is really doing. So now with .peek open, I'm going to go ahead and open that payload for DLL on our desktop, and that will load in as our Microsoft Win32 task scheduler. Granted, it's not really that. We could double click on it to be able to actually see some of the other info. Kind of interesting here, it does note a GitHub repository URL from Dahal and Task Scheduler. Well, this could very well not be malware and maybe just some package or code that they have tried to backdoor or add components to or extend capability to really run their payload. But it looks enough like regular Windows code. Some of the other classes or information in the binary or different symbols are likely obfuscated or set to a random gibberish name or are a bit more telling as to the actual intent of this payload. But the question is, what does the cradle actually do when payload 3 tries to invoke this? The first PowerShell code loads this binary data in, but ends up invoking one specific function with all these arguments. In fact, they get the type or the function delegate from the windmilled variable that we saw previously, base64 for what was the class library 1.home. Then they get the method out of it, which was malloplacenta or VAI, and they invoke the function. Soldier-like is a variable that actually isn't defined, so that's null, but the biosensors that they've defined above are the arguments with those interesting strings. So that clues us in the .NET assembly. We actually see the entry point being our class library 1 and home. Double-clicking on this to try to decompile or explore more of it, there is the VAI function, with all of the different variables or parameters and arguments that it will take. We can actually make sense of some of these, like startup, maybe registry key, name VBS, .NET framework, persistence, and others. With some nonsense surrounding it, it ultimately ends up defining a process and a task to run, and then it gets to some obfuscated code that isn't particularly things we can easily read or make sense of. We could keep trying and exploring this if we really wanted to, but I'll admit there's a lot of nonsense there. And if we tried to look at some of the other randomly named functions or variables, a lot of them continue to be obfuscated in a way that, well, d4 dot or other utilities don't seem to easily make sense of. If I keep scrolling, there is a lot of code here and plenty of others in those other randomly named snippets of code. Take a look at this one, KUSBQ8F7 blah blah blah. Lot of noise and nonsense there, and others that we don't need to try and make sense of within .peek. Let's move on to the dynamic analysis portion, moving on from the static analysis we've been doing so far. So to keep things easy, I'd like to run this malware sample in an analysis sandbox. And some of you might know I'm a big fan of any.run. What we could do is actually upload payload3.ps1 and our nerf file extension so that we could actually analyze this. That will end up actually downloading the archive.org lost in space wallpaper JPEG and extracting out the .NET assembly from the RGB color values, but it'll still get everything running just the same way that the malware did. Spinning this up, it looks like it'll automatically adjust and fix the file extension for me, and then PowerShell will run. It is downloading this. You can see the connections and threats as they are coming through, and it ends up running what would be MS build to put together the C# or .NET assembly. Letting this run a little bit more, it looks like that MS build process and the C# .NET assembly is actually async rat. For folks that aren't familiar, async rat is a extremely well-known, basically off-the-shelf, commoditized, low-tier remote access Trojan. One of the coolest things, though, is that any run could automatically track down the configuration, so all of the stuff that we couldn't make sense of, or at least we wouldn't want to, the strings inside that .NET assembly in .peek, it's been able to carve it out. It sees the command and control server, or the online resource, and the external hotspot that it tries to connect to, the domain offkkfd24.work.gd on port quad 5. Also digs into the mutex that it uses, where it will install, the certificates that are pertinent here, and the salt. Little tip off there from DCRat. So that's pretty dull, in my opinion, a little bit boring and dumb to just end up as another usual off-the-shelf async rat. Classic and cliche remote access Trojan, especially after at least one cutesy trick of hiding the payload in a archive.org JPEG image file and then a bitmap bytes inside the file. carved out of the RGB color values within the pixels. It had so much potential, and then is always boring, stupid stuff at the end. But we are not yet done. We can go take a look at what our apostrophe file was. Granted, I didn't see anything in the code that actually invoked this. I don't know if you did. And it really was never going to be called because it didn't have a .exe file extension anyway. It was just a single quotation mark or apostrophe that wouldn't have a file handler associated with it without a file extension. But it's looking like a Firefox installer. I can click through this, but I'm pretty sure it could very well just be Firefox. Yeah, it just seemingly installs Firefox with nothing else sketchy here. Unless I'm missing some parts of the puzzle pieces, hey, please let me know, but I don't think that apostrophe and Firefox installer was particularly part of the payload and attack chain here. All in all, that Discord CDN download, for being as serious as I can be here, Lesb1 and Mia Khalife, was totally malware in that images.leetspeak.js file. Ultimately ended up as async rat, boring and basic, but I did like that little trick of, hiding in the next payload within the color value pixels of another online file. And an especially neat trick, hiding that in the bytes of a lost in space wallpaper, literally stored and saved by archive.org.